Hey guys, we're AIDE Design. I'm Oliver.
I'm Aaron.
And I'm Swastik.
So, what is the Agua Clara infrastructure design engine? One problem that we've faced since Agua Clara's inception is that we need to build water treatment plants for communities of many different sizes, be it 1,000 people or 20,000 people. These communities will then have specific demands of how much drinking water that they're going to need for a given month or a given week. And so, thus we need to plan out different water treatment plants that are acceptable for each of these different communities. And so what AIDE does, or the Agua Clara Infrastructure Design Engine, is that it automatically redesigns these water treatment plant designs. And so AIDE is designed to take in a single variable, flow rates, and then run calculations based off of that variable. Then these calculations are put into 3D models, which will then reflect the finalized design of a water treatment plant for a given community. And so AIDE functions as a collection of interconnected modules through which data passes. And so we have both cloud modules and modules that also live on the user's computer. It all starts with Onshape and FeatureScript in the cloud. Onshape is a 3D modeling software that allows us to actually make and create these general water treatment plant designs. And so Onshape is a recent change that we made from Fusion 360 because Onshape works very well in the cloud, which will help us in the future with integration. Also, we are using FeatureScript, which is also residing in the cloud. FeatureScript is a proprietary language that works very closely with Onshape, and FeatureScript is strong in the sense that every 3D model in Onshape can be reflected as code in FeatureScript. And so we're using that for some of the parts in our water treatment plants. Then on the user's computer, we have two important Python packages that are used to accomplish the goal of AIDE, and one of them is OnShapePy. What OnShapePy does is it transfers data from the user's computer into Onshape in the cloud, which it can then use to edit those Onshape 3D models. And Agua Clara Design is a package that runs calculations in order to determine the physical parameters and dimensions of a water treatment plant. And so you can see that data passes through each of these modules in order to finally arrive in Onshape and create a finalized plant design for a given community.
So what does AIDE Design do? AIDE Design is tasked with writing Python code that calculates the geometric components of plants, of all the parts of a plant. So the Elefante, the Flocculator. In this example, we're doing the Elefante. So first, we wait for AIDE template to draw the model of the plant component in Onshape, and then we can write code that basically reconfigures it. So here, in class Elefante, excuse me, we access the Onshape model of the Elefante through the URL of the Onshape file, and then we write an initializer function that takes in Q and HL, flow rate and head loss as parameters. And then using these parameters, we can calculate the other dimensions of this plant component, such as number of rows and the height of the Elefante. And this can be done using knowledge from the Agua Clara textbook. So basically here, we can initialize an Elefante object with flow rate 40 and head loss 30, and then we can use that to calculate other things. And then basically, once we've done that, we can re-access the Onshape Elefante model and reconfigure it from there. Our code now uses an object-oriented approach. So in the old model, what we had is we had separate functions for calculating each dimension. So for example, here we have the number of rows. That has its separate function. So it takes in Q and HO, once again, flow rate and head loss as its parameters, and spits out the number of rows. So what that did was it basically just imported data from outside files. So that's not really that intuitive because it doesn't make sense to bring in data from outside files. So our new model, which is much more intuitive, assigns a Python class to each component of the water plant. So here, the Elefante has its own separate Python class. The Flocculator would have its own class. And each would have functions within that class to calculate its dimensions. So now it can calculate all the dimensions directly instead of importing data from outside files.
So here's what we've been doing this semester. We started by working on the core portion of the AIDE codebase. This is the structure of the codebase. As you can see, the design module, which is what AIDE design works on, is a submodule of the core module. So there's a lot of functionality within core which is used by design as well as used by other modules like research. So before we worked on design, we wanted to improve core such that it was easy to use by us and by others, just to make things easiest going forward. So the way we did that was rewrite the core functionality such that it was as consistent in style as possible, so that if there's any functionality that you want to use, you can easily predict how it will be implemented in core and how you would be able to use it in core. When core was initially created, this wasn't the case. So we finished that. But as for the rest of the semester, our work has been in creating these classes that we were talking about with using object-oriented design principles. So we've created this Elefante class, which takes in constraints like the flow rate of the entire plant and the water temperature, and outputs parameters of the Elefante, like cross-sectional area and the whole configuration, and passes those into OnShape, which then generates this model. So, which is nice. We've also done this same thing for the Flocculator, which generates this nice model, as well as partially completed it for the set tank here. And just a note about the set tank and the Flocculator, they are closely interrelated physically in the plant. So what that means is that since the set tank is partially finished in the code, our functionality of the flock and the set tank are both partially complete. So basically, the only thing that has complete functionality right now is the Elefante, but we're working right now on completing the rest, the set tank and the flock.
So we've been writing Wiki Documentation for our code. So how this works is we've been using Sphinx, and how this works is first we write a docstring in our code according to the Sphinx format, so they align. Then when we release this new code, our wiki is automatically updated with the new information. This makes it easier for users to understand how to use the actual Aquaflower package, and in the future we plan to add documentation on how to install the package as well as how to contribute to it. So how this works is each variable in the class has an entry in the docstring, and then this docstring is then transferred to the wiki in a more readable format, so it's easier to understand.
Here's an example of how this documentation would work for a function. So right here we have the function channel n, which will return the number of channels within the flocculator or entrance tank. And so within the docstring, we're going to be writing a brief description of the function, what it's going to return, and also the type that it's supposed to return. And then all this information in the docstring is then transferred over into Sphinx. And you can see that we have the exact same description, return, and return type that's automatically ported into our wiki. And so if you have any questions or recommendations, feel free to reach out to us at our emails. And here is our appendix slide of some useful things that you would like to see. Thank you very much for watching.